In this video, I will cover the wait methods for Selenium, the browser methods, web elements methods, and navigation methods were covered in previous videos. Number 4, the wait methods are a group of methods that pause between execution statements. We wait for a statement to finish before moving to the next statement. A question someone may ask is, why do we want our test scripts to pause between statements? We want our test scripts to pause between statements because of dynamic content on a web page. An example of dynamic content is a web page that has elements that you do not see when first opening the web page. Those elements wait a few seconds, then show up. Therefore, we need our test script to also wait a few seconds, then perform an action after the element shows up. Wait complications are one of the reasons we have errors with our Selenium automation test scripts. In this tutorial, we are going to discuss why we have wait complications, the different type of wait methods to handle those wait complications, then demo all of the Selenium wait methods. Let's start with the wait complications. Wait complications are outside components that cause problems with our test script. Some of those outside components are server location, server performance, machine performance, and JavaScript engine performance. Network is not in this list, but it's another outside component that causes wait problems. Server location causes wait problems because the information has to travel. Information travels to the server location, then it travels all the way back from the server location. When it comes to server performance, our browser sends a ping to the server asking for all of the information so the website can load. If our server's performance is slow, then it will take a long time to respond. Machine performance is different with fast machines and slow machines. A fast machine will render elements on a web page quick. On the other hand, a slow machine with small memory will run our test script slower than a fast machine. JavaScript engines are embedded in browsers and web servers. Therefore, the performance is important when testing web applications that have a lot of JavaScript. Something rendered on one browser may load faster than another browser. Here's 2 screenshots that compare browsers for a JavaScript benchmark test using JetStream. The URL is browserbench.org/JetStream. I ran a test on Firefox and Chrome. Firefox has a score of 159, while Chrome has a score of 137. To be honest, I ran a test on Internet Explorer 2 times, and no score was returned. The bigger score is better. In this case, we see Firefox outperform Chrome. In addition to the browser, the version of our browser dictates how fast or slow test scripts execute. Next is the different type of wait methods. By default, Selenium executes statements very fast. Soon as one statement is finished, Selenium immediately executes the next statement. That can be a problem because Selenium will not wait for a dynamic element. Therefore, we need to instruct Selenium to wait for dynamic elements before executing the next statement. If Selenium does not wait, then an exception shows up. The exception shows up because our test script is attempting to interact with an element that could have changed or may not be available. We have 5 Selenium wait method types to handle dynamic elements. Thread.sleep is not a Selenium wait method, although it causes execution to pause or sleep for a certain number of milliseconds. I added it to this list because many automation engineers implement thread.sleep as a wait method. However, it is not a wait method, but it is a sleep method. Thread.sleep is not efficient or reliable. It is not efficient because it will stay asleep for the time we set, even if our statement is finished and ready to move to the next statement. It is not reliable if we consider a wait complication, such as machine performance, where one machine could possibly run slower than another machine. For example, if we add a hard-coded value of 5,000 milliseconds, which is 5 seconds, to thread.sleep, a faster machine may render the elements in 4 seconds, but a slower machine may render the same elements in 6 seconds. As a result, the same test script will pass on one machine and fail on another machine. Page load timeout sets the wait time for a page to load. Set script timeout sets the wait time for JavaScript to execute. Implicit wait determines the wait time to search for an element. Explicit wait pauses execution until a time has expired or an expected condition is met. Fluent wait is a specialization of explicit wait, which also pauses until time has expired or an expected condition is met. Page load timeout, set script timeout, and implicit wait are 3 built-in Selenium wait methods. All 3 methods are configured using the timeouts interface. Now, let's demo the Selenium wait methods. Our first Selenium wait method is page load timeout. Page load timeout sets the wait time for a page to load. Driver.manage.timeouts.im. In this IntelliSense, we see all 3 built-in Selenium wait methods: implicit wait, page load timeout, and set script timeout. Select page load timeout. Enter 3 for time unit dot. Time unit represents different lengths of time, such as days, hours, and microseconds. Let's select milliseconds. Next, load the orange HRM page. Driver.get https://open source demo dot orangehrmlive.com. Print the title, sysout, what is the page title? Driver.getTitle, and run. As expected, our test script returned timeout exception because the page did not load in 3 milliseconds. This exception provides a good example of what happens if our page does not load in the max amount of time. Let's imagine if we have a requirement that states we need the page to load in 3 seconds. If the page does not load in 3 seconds, then we must report a defect. change our time from milliseconds to seconds. Selenium will wait a max of 3 seconds for the orange HRM page to load. If the page loads before 3 seconds, then execute the next statement, which is print title. Run again. Now the page loads without a problem. What is the page title? Orange HRM. The entire test script executed less than 1 second, 0.959. Recall from our introduction that thread.sleep is not a wait method, but it is a sleep method. I'm going to show you how it's a sleep method. Thread.sleep and 3000 milliseconds. Add throws declaration, import interrupted exception. Run again. We see the same result. Orange HRM is the page title. However, look and see how long it took for this test script to execute. 4 seconds. Thread.sleep waited for the whole 3 seconds, although the page had already loaded and was ready to execute the print statement. This is one of the reasons why we should not use thread.sleep as a wait method. It's not dynamic like page load timeout. That's it for Selenium wait method page load timeout. Next is implicit wait. Let's walk through this test script for an Ajax web page. Ajax stands for Asynchronous JavaScript and XML. First, we load the web page, which is Welcome to the Internet. This web page is powered by Elemental Selenium, where you can use Selenium like a pro by Dave Helfner. Next, we click the dynamic loading hyperlink. After clicking dynamic loading, the next step is to click example 2. The last step is to click the start button. Do you see how we are waiting for the dynamic element to load? Finally, in our test script, we are going to find hello world, get the text of hello world, then print hello world. Let's run our test script. Uh-oh, no such element exception. Unable to locate element. Which element? The string for hello world. Our test script executed so fast that it did not wait for the next step, which is find hello world. That's why Selenium provides wait methods so our execution can pause between these type of statements. If not, our test script will fail every time. Let's use implicit wait. Driver.manage.timeouts.implicit wait. The description states specifies the amount of time the driver should wait when searching for an element if it is not immediately present. This means Selenium will wait for all instances of driver. Enter 5, and time unit is seconds. Selenium will wait up to 5 seconds. Let's run. Now we see hello world and passed for our test script. Implicit wait would have waited for lines 44, 45, 46, and 48 because they have a driver instance. If the element was not found for those lines, then an exception would have been thrown. That's it for implicit wait. Next is explicit wait. This is the same test script from implicit wait, where we load the page, click the dynamic loading hyperlink, click example 2, then click the start button, followed by finding hello world, getting the text of hello world, and printing hello world. I'm going to run this test script again. It's going to fail because of this dynamic hello world element. Fail. Explicit wait is used on one web element at a time. For that one element, which is hello world, execution will pause until time has expired or an expected condition is met using the web driver class. Let's start by writing web driver wait and wait as the object reference equals new web driver wait. Pass in driver and timeout in seconds as 5 for the parameters. 5 represents the maximum number of seconds Selenium will wait for an element before throwing an exception. Here's the power of explicit wait. After clicking the start button, we write wait dot until expected conditions with an S dot. So far, we are going to wait until an expected condition is met. There's many of expected conditions. Our goal is to check if hello world is present. We can select visibility of elements located, which is an expectation for checking that an element is present. Locator will be by XPath. Go back to the application, inspect hello world, copy XPath, paste XPath. Let's run. Hello world is printed to the console. All of the expected conditions are examples that assist us with writing our own customized explicit wait statements. Let's break down explicit wait. With the first line, we have the WebDriver Wait class, which has a constructor of WebDriver Wait and 2 parameters, driver and 5. Let's view Java docs for the WebDriver Wait class. It has 3 constructors, 1, 2, and 3. We use the second constructor, which ignore instances of not found exception. Not found exception is an exception that is thrown when an element is not found. We see both parameters, driver and timeout in seconds. Driver is the WebDriver instance, while the timeout in seconds is the timeout in seconds when an expectation is called. The next line is wait until expected conditions. Wait is the object reference of the WebDriver Wait class. Until is a method that repeats until one of the following occurs. Number 1, the function returns neither null nor false. Number 2, the function throws an unignored exception. Number 3, the timeout expires. Number 4, the current thread is interrupted. Since hello world was returned, number 1 applies to our test script because hello world is not null nor false. Expected conditions is a class that has so many methods. However, we use visibility of elements located, and the by locator was XPath. That's it for explicit wait. Let's recap and discuss implicit wait versus explicit wait. These are the 2 most popular Selenium wait method types. Implicit wait uses a single code line, while explicit wait uses multiple code lines. Implicit wait is used on all web elements. That one code line for implicit wait impacts all web elements in that test script. However, explicit wait sets a wait time that is used on one web element. Expected conditions are not required for implicit wait, but expected conditions are required for explicit wait. Here's a list of 16 expected conditions. This is not the complete list. All of them would not fit in this table. I think it's nearly 20 expected conditions that are missing. If we choose to, we can create our own customized explicit wait using the expected conditions class. Now, here's the controversy between implicit wait and explicit wait. Which one should we use? It's recommended we use explicit wait over implicit wait. We must handle the slow loading elements like hello world on an element by element basis. According to Mastering Selenium WebDriver by Mark Collins, implicit waits were not originally a part of the WebDriver API. They are a hangover from the old Selenium 1 API. Implicit wait was not going to be added to Selenium WebDriver API, but people were used to it and wanted it back. There's at least 2 reasons for choosing explicit wait rather than implicit wait. The first reason is implicit wait can slow down our test. And the second reason is implicit wait can break explicit wait. Next is fluent wait. WebDriver wait extends fluent wait, which pauses execution until the time has expired or an expected condition is met. WebDriver wait is a specialization of fluent wait that uses WebDriver instances. Therefore, at the core of explicit wait is fluent wait, because explicit wait implements WebDriver wait. Here's a sample of fluent wait that I will use in this demo. Go to Tools QA and take a look at our AUT, application under test. We will test a countdown timer that now shows buzz buzz. The timer starts at 40, count down to 0, then show buzz buzz. Driver.get. Paste the URL. Fluent wait. Control space. Copy and paste the sample. Let's take care of the red X's and the lines. Import wait, fluent wait, and no such element exception. There's two no such element exception packages, but we will select the package from org.openqa.selenium. Import function by selecting the package com.google.common.base. Modify the seconds to include time unit. Dot. Time unit dot. We see the first comment states waiting 30 seconds for an element to be present on the page. That comment is referring to the with timeout method, which sets how long to wait for the condition to be true. The next comment states checking for its presence once every 5 seconds. This comment refers to the polling every method, which sets how often the condition should be evaluated. The ignoring method will ignore the no such element exception. We see parameters show exception to ignore. I will change the polling every method to 1 second. This test script will fail because the countdown timer on Tools QA starts at 40 and the with timeout method remains at 30. In our demos, I don't want to always show you the happy path scenarios, how our test script looks when it passes, but also show the failures. This will return an exception. Let's modify the sampler code. First, I will change foo to element. Next, we must find the element, which is countdown timer. Therefore, I will write driver dot find element by XPath. Then go back to our AUT Tools QA and get the XPath's value. Inspect the element, copy XPath, and paste XPath. Assign the value to web element timer. After finding buzz, we want to get the text of buzz. So let's write timer.getText. Then assign the value to string message timer. The last modification is to write an if-then-else statement. You can watch video number 15, Java's conditional if statements, to get a better understanding of all three if statements. Within this if statement, we're going to print buzz. If message timer equals buzz, then print the sound of an opportunity clock is message timer. Else print message timer. Here's a breakdown of this if statement. If the message timer equals buzz, then print the sound of an opportunity clock is buzz. If it does not equals buzz, then print whatever the message shows on Tools QA after the clock reaches 40 seconds. Do you see the red X and how our return type is web element? That means we must return a web element. The error message shows this method must return a result of type web element. In this case, our web element is timer. So we must write return timer after printing buzz and write return null if the message timer is not buzz. Now the error message goes away. You can watch video number 9, relationship between Java's classes, objects, and methods to get more information about return types. We are finished modifying the sample code. This test script will wait until the timeout expires or the condition becomes true. What is the condition? The condition is when buzz shows up on the page. Our code will poll every second, which means it will check the condition every second. The no such element exception will get ignored. We can add more exceptions to ignore if we choose to. The purpose of this function is to find buzz and return buzz. We have two arguments, WebDriver and WebElement. WebDriver is the parameter for the apply method. WebElement is the return type for the apply method. WebDriver is the input, while WebElement is the output. Driver is the input parameter, which helps find an element. The element is assigned to WebElement timer. We get the text, then assign the value to message timer. When message timer equals buzz, the value is printed and returned as an output. Now let's run demo Fluent Wait. We see the polling for every second starting at 40, then counting down. This test script should fail when the countdown timer reaches 10 because we are waiting 30 seconds. Yes, the timeout exception showed up. Expected condition failed. Tried for 30 seconds with 1 second interval. This time, the test script will pass when I change 30 to 41. I will also change the comments 30 to 41 and 5 to 1. Run again. The sound of an opportunity clock is buzz buzz. An advantage of using Fluent Wait with the function element is the flexibility of passing an input object type and returning any object type. Object type, input. Object type, return. In this scenario, we pass WebDriver and returned web element. That's it for Fluent Wait. Thank you for watching Selenium Wait Methods. You can download your transcript, presentation, and automation code at tinyurl.com/selenium-wait-methods. https://tinyurl.com/SELENIUM-wait-methods.
Online courses coming soon. Books available in paperback, ebook, and PDF. All Part 1 ebooks and PDF documents are free. Programming books for UFT. Programming books for Java. Here's the Selenium automation book. And TestNG. Subscribe to get notification of future videos. Don't forget to like, comment, and share.